Okay, so here we have, good morning, CET 236, lecture 13, right? Just a reminder about the Zybook, although I think we're pretty much done with that. So that's where we are, right? We have today, we have Thanksgiving, right? We have class on the 4th, and then we have finals. I have not finalised the final yet, if that makes sense. I haven't finished it. I'm going to do it a little differently from what I said, not too differently, a little differently. I'm going to have a couple of questions that are mandatory, but you will see that they are, there's a bit of wiggle room within each of them, right? So, and then I'm going to have another long list of questions, which I think I'll get you to answer 4 of the long list of questions. And the long list of questions should cover most of the syllabus. I'm going to aim to release that over the weekend. I didn't quite get time to finish it for today, unfortunately. But I will release the paper. I think I'm just going to go with a completely oral final, no written component to it at all. So it's going to be one and done. And we'll see how we go.
So I'm not sure if you answered this, but will we be able to use answers that we so say you give us the questions and we find the answers, will we be able to use that on the exam?
It is completely open, yes. So provided you're not Googling stuff and delaying while you're on the call or the Discord, I'm fine. I'm looking for reasonably quick, coherent answers then and there. And however you want to be able to do that, sometimes some people prefer having notes, some people prefer having diagrams, some people prefer having particular web pages open. That is okay. The issue is I want you to learn the material and be able to talk about the material. I think a lot of the adherence to written examinations is largely historical. I don't believe it's pedagogically motivated. I think you're better off learning stuff by being able to take it in and being able to pull it out of you. Does that, sorry, that's a bit of a diatribe. Does that answer the question? Yeah. Okay. So that's where we are with stuff. I've backed off to 6 labs and lab 7 is optional. And that means it's bonus if you want to put that in. That's what we're doing. We're building a CPU. I've decided I'm not going to talk about the chapter 7. What I want to do with that is I want to put together a whatever you call it, a video talking through it, because I want to spend most of the time today. I need to talk a little bit about processors. I want to spend most of today trying to get this CPU built. And there's a lot of issues that I haven't done the CPU build in class before, so there's a lot of issues that I didn't foresee we're going to have to deal with. And then so processes. So one of the reasons I get people to do that baseball counter is it's a nice, simpler problem that exhibits issues with Vhdl, right? So let's have a quick look at it, right? So just a reminder of what the baseball counter is. It's got, let me do some drawing. Right, so you can probably do that. So it's got a button that indicates that a ball has been pitched. It's got a button that indicates a strike has been pitched. It has a 7-segment display, and that should actually say just ball, and this should say, you got that one, this should say ball count, right, and this one should say, probably should make that a little thicker so we can see it perhaps a bit better, and this one should say strike count. And then there's some LEDs to flash. Right, so if you try to solve this problem, right, even if you were just doing it in a standard programming language, you'd see, well, I probably need an integer that is my ball count, right, and I probably need an integer that is my strike count, and actually there's another button which is the reset count button, right, so if the batter hits, then the ball count and the strike count go back to 0. Now the problem is it's really hard to deal with multiple inputs in a single process, right? So if we just try to deal with the reset button, the ball button, and the strike button in one process, it won't happen. So you've got to have a process for reset, a process for ball, a process for strike. And then the problem is these two counts, the ball count and the strike count, affect each other, right? If the ball count goes up to 4, then both counts need to reset. If the strike count goes up to 3, both counts need to reset. So that's a problem again, because you're dealing with the strike counter in one process and the ball counter in the other process. So you need if you like, a hidden process that deals with that cross coupling between the ball count and the strike count. Okay, so it's the fact that even though it looks like a simple problem, it's the fact that it ends up having several pieces that you've got to tease apart and do individually, and then couple them together. Let's have a look at some VHDL to try and illustrate the point a bit better. Now, I don't know whether that's readable. Let's make it a little better. A little bigger, maybe. So this isn't actually out of an implementation of the strike counter, but what it does is it tries to deal with things that are cross-coupled, right? So here, this first process, the signal management process, for a start, it just deals with the clock, and actually this is a, let me go to the next slide. I've got to talk about, this is another issue, sorry. Let's try this. Right, so here's the issue. So here's a process that just deals with the balls, right? So for a start, we've got the clock, so we're doing everything synchronously. And if we've got a rising, sorry, this is a falling edge, right? So we've got an event on the clock, so that the signal has changed, and it's gone to be a value of 0. So it's a falling edge. Then what we do is we have a reset signal for the balls, and we don't want to reset that all the time, but we initialize it to 0, and that's what I need to talk about in the other slide. And then we look at the ball count, and if it's greater than 3, then we reset, or if the new batter, I think, is the reset button. The new batter button has been pressed. Remember, our device is active low, so this is active low. Or if our strikes are greater than 2, then we reset and we fall out. Okay, so that's being done synchronously. So then, how do the balls get dealt? How does the value of the balls get changed, right? We have something has changed, right? And if our signal reset balls is 1, then we set the ball count back to 0. If our input is 0, right, so this is on a falling edge, then we just increment the ball count. Any guesses as to what this means? dB underscore B. So remember what it is? It's dealing with the ball count. So it's going to be, yeah, debounce. So there's a signal coming in, right, there's a signal coming in to indicate the balls, that the ball switch has been pressed, but it's got to be debounced. So we use this prefix dB to indicate that it was a debounce switch. Right, so if the debounce switch has been pressed, right, again remember it's active low, so that means it's gone down. Then we increment the ball count.
So does that line need the increment bars process GD?
What does this mean?
Yeah, like is that a
So-
variable?
So whenever you define a process, you can give the process a name. You don't have to, I believe, but you can give the process a name, which is what increment balls is here, and what do balls is here, right? That's just the name of the process to be able to identify it. Process is just the keyword that starts a process, and then the other piece, the argument, and you can have one or more or zero signals in the argument. That's called the sensitivity list. If a process doesn't have an argument in the sensitivity list, as soon as the process finishes, it starts again.
So the process is like a function?
Yeah,
Like
well,
password.
so a process is a function-ish. There are functions here as well in Vhdl, but a process is a sequence of actions that can happen repetitively. Right? Remember, when we write Vhdl normally, everything's happening at once. There's no sequence. What a process lets us do is sequence events. And that's we can really only write an if statement inside a process. What the green, the sensitivity list does is the process only executes. So it's more like a small program than a function as such, right? The process only executes if any of the signals in the sensitivity list change. Okay, so if the button gets pressed, this gets executed. If the button is released, this gets executed. Right? Because our switches are active low, when you press the button, it goes from 1 to 0. That's a change. When you release the button, it goes from 0 to 1. That's also a change. Because of this line here, there's two parts to this. There's an asynchronous part. If reset balls is 1, this will always execute regardless, provided we're in here. This line here, the ball increment, only happens after we've pressed the ball counter button down. It doesn't happen when we lift the ball button, when we take our finger off the ball button, because this event is saying there was a change in the value of the debounced balls switch, and it had to change to a value of 0. Does that answer the question, Michael?
How does that make sense to you? So you said that the first if line always happens, but it's an if.
Well, it always tests this case, right?
But it's not always true, though.
That's true, yes. That's true. If it's not true, then it tests this piece.
You
Yeah.
said it always happens, so that confused me.
Okay, sorry. It always gets tested. The issue is it doesn't depend on a change in the value. It's only on the actual value. This one depends on a change in the value because of this event piece. Okay? Okay. So what I'm trying to show here is that cross coupling piece. Now, go back to this. The issue on the previous, now did I put another slide in here? Oh, I didn't. Okay. So the other issue that I wanted to raise that we haven't seen yet in quarters is sometimes when you do a quarters compilation, it will give you a warning. The warning says something like, created a register. And that doesn't make any real sense. And I'll tell you what the compiler is trying to tell you. You'll notice up here in the do balls part, let's go with purple, maybe yellow. The yellow. You'll notice I've done this piece and I've done this piece. Right? I've set reset balls to 0, and then if the condition is true, I've set reset balls to 1. There's two reasons for that. One reason is I do want to make sure, I want to be able to set reset balls to 0, right? So that's why that's there first. The trouble is, if you set a variable within a process and that setting is conditional, it's the compiler. So the upshot of it being conditional is there's a way to get from the start of the process to the end of the process without setting the variable. Right? Here I can't get, apart from the big if condition. Within that, if the variable gets set, it always, if that first condition, the div clock event, if that happens, reset B is always set. If I didn't do that first reset B line, setting it to 0, this process would have to remember the value of reset B, because any changes to reset B don't happen until the end of the process. So let's go to the previous, and it's a bit clearer here maybe. Right here, got to think of the right way to explain this. Right, so I have a process. Right? And I begin it. right? If I have something simple like this, right? So there's a condition, and if the condition is true, then I set the value to 0, the variable value to 0. Anytime you come through a process, any changes to value don't happen until here, right? So down here is when value changes. It doesn't change here. It's only once it's through. The trouble with this particular process is I need to remember what value was here. Because I have to set it to something down here. If I go all the way through and I don't go into this if condition, okay, it stays the same, but the process still needs to set it because it had the possibility of changing. So what the compiler does with that remember is it makes a register. To store the value at the start of the process. If you have an else condition, if you added an else condition here that also set the value, then there'd be no way to get through this process without actually setting a value to the variable. So if there were an else condition, if I added an else value is set to 1 or value is set to something else, then I wouldn't have to remember what value was at the beginning. I always set it to something or the other. Okay? Like I said, we haven't come across the register issue before. I think that may only show up once we start compiling stuff again. I'm hoping we can do that maybe later today, more likely next time we meet. I don't know if that's clear as mud or what, but that's the issue.
Could we just define it at the start? Like just say integer value, and then when the process does go through and the value does change.
Right, well the trouble with defining it outside is that it's just an initialization. It's still the compiler doesn't necessarily know that the compiler doesn't necessarily know that it's going to go back to that initialization, right? If it's changed anywhere else. So you've got to within the one process, you've got to be able to well, where's my value process? You've got to be able to know what the value of value is at the end here. And if you don't set value in every possible path through the process, it's going to generate a register. It may be that generating a register is okay, but yeah. So there's two key pieces to this. One of them is if you set a value through a process, set it in every path through the process. The other piece is the only time anything you change in the process actually changes is down here. It doesn't change immediately. So if there's other stuff happening in the process, it only changes at the end. So for example, let's just do another handwritten example. If I do something like this, actually, let's just do with let's just make all of these integers, right? So right, we can just do addition. It should be y. Why am I writing begin again? I want to write end down here. Right, so if I have this process that takes the value of x and adds 1 to it, takes the value of y and adds 1 to it, and then takes the value, makes the value of z x plus y. Let me let's do a quick pop quiz, right? At the start of the process, x is 10 and y is 3. So I want everybody to tell me what the values of x, y, and z are. Write it down once you get to the end of the process. At the start of the process, x is 10 and y is 3, and then we don't know what z is, but it's going to be set up. So what are the values of x, y, and z at the end of the process? Mohammed, I'm gonna go around everybody. So Mohammed, what do you? Let's try and take a tally or something. What do you think?
X is 11, y is 4, z is 15.
And z is
15.
15. Eric?
Same thing.
Michael?
Well, before you said nothing changes until we get to the end. So I'm going to say X and Y are the same what they said, but Z is going to be 13.
Okay, we got a 13. Fahim?
It's going to be the same, the first one, 11, 4, 15.
Okay, so we've got 3 here and one there. Matt?
I say z is going to be 13, y 4, and so on.
Okay, so we've got I'll use tally marks. There's 2. I probably should use tally marks for the other one. So we've got 3. And David?
X is 11, and Y is 4, and Z is 13.
Okay, so we've got another 13. Yeah, wrong one. Kevin, how about you? You 15? Yeah, 11, 4, 15. Okay, so we've got to keep going to the touchpad. I really should buy myself a Surface or something. Anas, how about you? 13. 13. Got to keep the scores even.
Yeah.
Emily?
13.
13. Okay. And Michael? Oh, I missed Michael Gallagher. I'm sorry. Michael Gallagher. Let's go with Michael Gallagher first.
What's this?
Oh, Michael Frederick. I'll explain. Michael Frederick.
Explain it again.
Okay, so
You're not gonna get second grade.
Something to think about.
15. Okay. So Michael, do you still want me to explain it
Still
again?
gotta explain that.
Okay. So
Is it after the process or like before?
yeah, I think I said.
That's the whole premise of this.
Right? That's what I said. So what's your final answer is 15? So we're completely split. The answer is 30. Right? Because the value of x and y when you get here is still 10 and 3. They only change once you get here. Right? It's not necessarily intuitive. So I'm actually really happy that we had a half and half split. That means it's an important issue, right? So those values, whatever x, y, anything that gets set in a process doesn't change until you exit the process. So that's the takeaway here. That's the answer there, 13. Okay. Okay, where are we? We are a bit early for a break. But I need to talk a little bit about stuff first. So I was saying to the class earlier before we started, there's a couple of things that I haven't done this CPU project before with the class, right? So there's a few things I didn't think about. I should have, but I didn't think about before we started that we need to address. One of them is, let's go to our architecture, right? I think we know pretty much what's happening. I think of the submissions I've seen for the second draft, most of them have are a good improvement on the previous submissions. One thing that is missing from this diagram that I should have pointed out is, I don't know if you know this, but computers are synchronous, right? They have a clock. and there's no clock on this diagram. So just about every one of these devices should have a clock input. Now that's as much on me as anybody else, right? It's the selling point of these things is usually 4 gigahertz, 1.2 gigahertz clock frequency. So we should have picked that up a little bit more. So that's one thing. Another thing is, and it's more of a software engineering thing than anything else, names. The submissions I've seen all have good names. The trouble is they all have good different names. So we need to come to some sort of an agreement about a naming scheme for the different signals that we have here. I think all of them are pretty good, it's just they're different. And if you're looking at the system as a whole, it's then going to be hard to track things down if the names are different everywhere. Okay, so we need to come up with and I really don't care what the naming scheme is. I do care that there is a naming scheme and that it's adhered to. So we're going to have to deal with that. Okay. Now I haven't seen too many submissions, but what I thought I would do is get the people who have submitted stuff to talk us through their entity statements. So Emily, if I could start with you, I know you had a submission. I'm going to have to check the other ones. I think Matt, you might be next, and then there was somebody else, but I think it might have been Kevin. But let's start with Emily and Matt. So Emily, if you could just talk us through what your reasoning was for the entity statement here while we've got the diagram, then I'll switch to the code so you can talk about it in a bit more detail. Okay, can you explain from here and then I'll go to the code?
So I had 5 different inputs. My first input being R and S, and these are basically the different operands, and they're 16-bit integers. So I wrote 15 down to 0 for that. And then I decided to split it into 2. I know you had a question about why I put I there. It's because I switched it to be operands and operation, so that then the operation, like logical operations, or determining what operation is going to be, like R plus S or S minus R, kind of to distinguish that and make it separate. And then I had to carry in a clock and then another input to tell whether it's active or not. And as far as my outputs go, it was resulting in different flags, like carry flag, sign flag, 0 flag, and then my result flag.
Okay, so let's just switch to the, I should have fired that up before. Oh well, we'll switch to the repository on GitHub once my computer wakes up and fires up Chrome. So one of the things I've been doing recently is analyzing code, and this computer hasn't been too bad, except there's this tool called Doxygen that auto-generates some pieces of code, and the trouble with the code base I'm analysing is every time I run Doxygen, it fills up whatever disk I'm on. And the last time I ran it, it filled up 30 gigabytes of documentation, which was a little silly. Sorry. So I'm thinking I need a NAS or something to do that. Okay, so let's go to Vhdl and ALU. Right, so here's so Emily, you want to just talk us through line by line?
Yeah, so R and S, those are my operands, and that's gonna be my 16-bit, so that's why it's 1590. Then I is my operation, and like I put 5 down to 3, but I don't really know if that numbering is correct. The reason why I did it like that is because on one slide, like looking at the truth table, like I wrote it down like in my notebook, but I have 5 different single variable options, and then I have 3 multi-variable options. So I wasn't really sure if that was correct numbering, but I put it there because that's what I thought. And then the last 3 are just the single bit to carry, and also the clock, and then to tell whether it's active or not.
The enable.
Yeah, CE is the enabler. And then for my outputs, I have the 3 different flags, and then for F, I put that as my result flag, which is also the 16-bit output.
Yep, well, that's good. I'm a little worried that this is highlighted as a keyword.
Okay.
So we may have to change that if it is actually a VHDL keyword. This is GitHub, so
Okay.
it may not. So let's just have a look at I again, and let's see if I've got the slide here. Maybe. Oh, I see. So you were taking it out of this one here, is that right? Okay. So I don't know, right? I haven't built this before, but my guess would be that all of this information is something that's completely internal to the ALU. So it doesn't need to come in, it doesn't need to go out. The only thing that needs to go out of the ALU is whatever this is telling it to do. So the program counter needs to do something sometimes. Different destinations need to change their values, and this is the value that those destinations need to change to. Okay, but all of these things are happening internal to the ALU. I think, I'm not sure, but I think the ALU is going to be pretty complicated. Not too bad, but we can put all of it on one slide, but the code to implement this is going to be a little bit tricky.
I just tried.
Thank you. I think you were the first one to come in with a submission, so that's really good. So, Matt, I've forgotten. Oh, you did the mux, yeah?
Yes.
Okay, so I'll go back to the code, but if you can just talk us through, if I can zoom in enough. So there's the mux, there's 2 of them. Can you explain from here, and then I'll take you to the code and you can explain that piece, yeah?
So the mux, it has 4 inputs. 1 from the register, 1 from memory. Then we have a clock, and then we have the control bit. The control bit kind of dictates what gets pushed.
Okay, I think that's, let me just take you,
A little summary.
did you,
I don't think I pushed my most recent version to the main branch.
okay, so let's
Maybe
get,
I have to go to mine.
yeah, let's do that. There you go. And up here. Okay, so there's the entity state. Can you talk us through that?
So we registered in IM or in memory. Both of them will be about 16 bits or 15 down to 0. The clock is the clock, I guess. And then the control bit dictates which one to, well, which to push the data from the data register or the data that's coming from memory. And then about 16 output, that's what would be my output. That would carry the data that came from either the data register and in memory. And go down a little bit to like the vector. And then the right edge of the clock, the control bit is 0. My output would equal the data register and then well, it would equal 0. It should equal data that came from memory. That's how I think it would.
Yeah, no, I think this looks pretty good. I think there's, so there was a bit of confusion in the first iteration about what the MUX was actually doing, but I think we resolved that. But I think this is pretty close to what we need to do. I don't think there's much else to be done. So I'm going to talk about religious wars. Not spiritual religious wars. I'm going to talk about programming religious wars. Right? Programming religious wars are often about the most inconsequential thing. And one of those things that I've come across, one of them is, and it's a non-event these days, but it used to be there was this big rivalry between the people who used the text editor VI, or it's Vim these days, and the people who used the text editor Emacs, right? And they're two completely separate beasts. They both do really nice jobs, but ne'er the twain shall meet. One of the other places where people get into, I call it religious wars, is in naming conventions, right? And there's a few things here that set my software engineering nerves a jangling, right? And one of them is capitalizations versus not capitalizations, right? The other one is using underscores versus not using underscores. Yet another one, and I it's not on you, Matt, at all. I'm just, you will come across this if you ever have to do any software, right? The other thing is using acronyms versus not using acronyms, right? So there's a functionally, this I don't see anything wrong with what's here. This is really good, and I think this is the most complete submission I've seen. But like I said, there's these procedural things that maybe we should talk about as a class in order to get some of the naming right. Okay? And it, Emily's had similar issues. I just saw this one more. I think I saw this one more as an example of some of the issues that I've come across previously. Okay. Okay. I think Kevin, and then I think Eric, you had a submission. Is that right? Yeah. So let me. Kevin, did you merge your submission, or is it still on your branch? You did merge?
Yeah.
Okay. So let's go back to main. And I have forgotten which your component was.
Program counter.
The program counter, that's right. So let's just go back to the picture and talk us through, just so we can all remember where it is.
I tried to make a PC.
Yep, okay.
So, as a 16-bit PC, a program counter with an input of a reset, A register output, A register output goes into the PC. And I considered the C, I don't know, but I understood it after you said it that we didn't have a clock. I thought that was a C for a clock, I don't know. So that's what I assumed, that it was a clock input. But
Okay.
now if we change the diagram, it was gonna have 4 inputs other than 3. So that would be a failure, right?
Right, and that's another thing that we haven't quite got to the bottom of, is what all these C's mean.
Yeah,
right?
because I assumed it as a clock, but then if we add if a clock is a different input, then it would be 4 inputs. So
Yep.
carry in a clock.
That's okay. That's just one of the things we've got to nail
And
down.
then the output is a program counter output.
Okay, so let's have a look at the code. And you're on main, so let's go there and then go to the program counter. There we go.
So yeah, I assumed the C was the clock, so I went with 3 inputs, one being the clock, second being the second being the reset. That was a 2C. That's what I want to put it. Yeah.
Right.
And then the other one being the A register output. That's the in PC right there. You have 15 to downtown. That's 15 to zero. And then the output was the PC over to the 15 down.
Okay.
I'm still working on it, but I just wanna.
No,
I didn't think it was right. when I
This
first
is
made it.
I think this is fine. This is a good start, and it's actually showing us some of the vagueness of where we are at the moment, right? I think it was Emily sort of covered it as well, in that we're not sure what those control bits are doing, right? So I think that's fine, and that's okay. Okay. So another aspect of the software. That's what I should call it. The soft wars. Another aspect of having arguments while coding is prefixes. It used to be that I think Microsoft started it, or at least that's where it became popular. There's this idea of Hungarian notation for software. And Hungarian notation says that you should encode the type of the variable in the name of the variable. Right, so if in C or C++, if you had a pointer variable, then the first letter of that variable name would be a small p. If you had an integer variable, then the first letter of that would be an M. The problem with that interpretation of Hungarian notation is that the type of the variable can change. It may be that we started off with the variable being an integer, but then you decided you needed 3.5 as an option instead of 3 or 4. So you change the type of the variable to a float or a double. Then you've got to change the name of the variable everywhere it's used to adhere to that Hungarian notation. But people don't. The way that idea of encoding something about the variable in the name of the variable has morphed a little bit, so it's no longer usual that the P or the N or what have you, F, for floats. But when you define things like an interface, then often interfaces start with an I, a capital I. And I can see why this is a nice way to name stuff, right? It's very clear what the inputs are, it's very clear what the outputs are. The other thing I will note, just compare it between Emily's, Matt's, and Kevin's, is all of them have a clock input. One of them is called CLK, one of them is called CLOCK, one of them is called I_CLK. Right? I think we need a bit more consistency. I'm not sure what the right answer is, but I tend to prefer the plainer names. It's a toss-up for me between CLK and CLOCK. I like CLOCK just because it's expressive. One thing that has happened in software is people now tend to prefer expressive long names for variables. Provided they're chosen well, they can mean you don't have to write comments, right? Or at least you don't have to write as many comments. So please, I think, use expressive names. So I think A_register is a good name. I think in is maybe not as expressive, right? So another issue that happens is and it's actually happened here, is people are used to writing file names with spaces in them. Right? If all operating systems let you do that, no operating system deals with it well every time. None of them. Linux doesn't do it properly. Windows doesn't do it properly. Android, iOS, none of them deal with it properly every time. So when I was working with the company I used to work with, we had a rule that said no spaces, no cases. Right? So never use a space in a name, and you can't use a space in a variable name, so this isn't really about variables. But I tend to prefer lowercase. Camel case is okay sometimes, but I would suggest for our variables maybe try and keep them a little bit longer and lowercase. Eric, I forgot what you were doing. What?
The top level entity?
The top level entity. Ooh, that's a scary one. So that's everything, really, isn't it?
I just did the inputs and outputs to like the overall.
Okay. So why don't we? And you integrated it into main, yeah?
It should be.
I think I saw it on main. So let's have a look. Top level entity. Okay, do you want to talk us through?
Sure. So, yeah, like I said, I just took the schematic from the lecture we had last time where we were going through each input and output. So the top two are 16-bit inputs, the instruction input, and the memory input. And I believe that R is the reset input. Then for the 3 outputs, we have the output of the memory, the address of the memory, and the program counter. And that right memory one was confusing me a little bit. Wasn't too sure what that is exactly doing.
Okay. So, reset, small r, right? Just based on what I just talked about. So one of the challenges with this project is that it's wheels within wheels, right? It's a systems engineering problem. I was fortunate enough to have. So I'm an engineer, right? I've been an engineer for a while, and when I was looking at doing grad school, I thought about trying to come to the US, and one of the schools I looked at coming to was MIT, and the problem with that was if I stayed in Australia, I already had a scholarship. Whereas if I came to the US, the difference for me at the time was about 60 grand a year, right? And I found a really good school in Australia, and I'm very happy I went there. But who doesn't like, as an engineer, who doesn't like MIT, right? It's a fabulous school. So when I was working at United Technologies Research Centre, and one of the things they do for employees is they had at the time, the CEO was a guy called George David, and he had a statement that he wanted United Technologies to have the best educated workforce on the planet. And so you could do lots of extra study if you wanted, and they paid for it. So I was fortunate enough to do a graduate certificate in system design and management at MIT remotely, and with 2 one-week residential sessions, which was fabulous. All on the company dime, which was nice. Dime and time. I could take work time to go to the one-week sessions. Anyway, one of the guys who was one of the lecturers was a guy called Ed Crowley, who was head of aerospace or something there, but he taught systems engineering. And one of Ed Crowley's claims to fame is NASA got him to enumerate all the possible ways NASA could get from here to Mars. And they had every cockamamie scheme under the sun, and they evaluated all of them as, do we go to the moon first and then to Mars? Do we go from here to lunar orbit to Mars orbit down to the ground? How do we do this? and he had this enormous decision tree about how to do all that. Anyway, this is a complete ramble. But he, one of the things he said, and it's a completely facetious statement, is a system. He was trying to define what a system was. A system is a system of systems, right? It's a completely facetious statement, and where I'm getting to with this, Eric, is remember what we're trying to do is we're trying to build something on the board that has maybe some outputs to the 7-segment displays and the other thing. And I do notice you've called your entity CPU, right? The top level entity in the Quartus project, though, is going to need to connect this CPU to the memory, to any reset buttons, or so there's the output of the memory, right? So I'm not sure. It's all a little bit meta, right? You've got the ALU and you've got the program counter, and I think that's what this is, right? It's connecting those things together. But then we've got to think about how how memory and how the 7-segment displays and the buttons get connected up. And I think what I might do is I might have a think about that for me, and then we'll use this entity to connect the to make that diagram. Okay. But no, this looks pretty good. This looks pretty good for that diagram. We've got to figure out. So the thing we're missing, and it reset. Let's see if we can go back to our do we have no? So that's something I think we need to do, is to figure out what goes around this. So what Eric's done is tried to capture this, and what we need to do is, where's the memory? We need another entity outside of that to capture the memory, the 7-segment displays, the buttons, all that sort of stuff. Okay, I've been talking for too long. Any questions so far? Has anybody else made a submission for the second one? I think those were the only ones I saw. Okay, I'd like to try and get through those today and have everybody else talk through them, so we can start maybe thinking about connecting them together. How they work is another issue. I think Matt has the mux pretty much done, but we need to think about how to get all the internals working. I think the ALU is going to take a lot, so we might have to give Emily some help on putting that together. We'll see how that works. Any questions so far? Okay, let's take a 15-minute break, and then we'll figure out what to do next.
So, I have a personal question.
Uh-huh.
So for my component, I have the seven-segment display.
Uh-huh.
And I was wondering, so I know the output would be the actual 7-segment, which is 6 down to 0, but the input, because I know on the PC output is 16 bits, but would it make sense that so that's the output, so the input to the display, would it make sense that it would also be 16 bits?
Right, so I'm wondering, what do we do about that? So one thing.
Because I understand the grand scheme of things.
Yeah.
Like you just want to display, where the program counter is actually pointing. They display the address, I guess. Yeah, so I understand that, but it's not. Again, it's not 16 bits.
So one thing I think we've got to do, so let's break it down. Let's make the first thing, let's just say you're right, that's what you've got to display, right? So the output is seven lines, right? And then the thing you've got to think about is what goes in. And I think the right thing to put in is just 4 bits. Right?
Which gives us 16 different values.
Because there's, right, so there's 0 to 9, but then you can also get A, B, C, D, E, and F, right? You can display those. So I would think that the base level thing, right, let's call it 7S, is that just like that. But that doesn't connect up to the rest of it, right? So I think what that means is we need some other component, I don't know what it is yet, I'm making it up as I go along, but I said, I think that means,
Exactly.
right?
Three additional ones to display.
Right. You need
16 bits.
You need something like that you need 4 of these to display 0 to 4, 5 to 8, 9 to.
So are we treating each? So I know it comes with 4 sections on the board. So are we treating those 4 sections separately? Ultimately?
Yes. So, well, that's the other thing. We need to figure out how the board goes, because remember the board just has. I've forgotten what the board has. Let's see if we can figure out what the board has. Let's go with my guitar. It's not quite right, but let's.
So this is kind of similar to the 4-bit adder, no? In a way? The 4-bit adder?
Yeah, let me.
Like
Yes.
when we have 4.
Right, 4
four-
components.
Exactly.
Yeah, exactly. So, but let's just have a look. Oops. I thought I.
You pressed the button and did something.
Yeah, I didn't press it enough. There we go. Maybe. Right, so here's what's on the board. So this isn't going to work. What I drew here, because what we've got is
Only 4.
well, there's a select line, right, for each of the segments, and then there's actually 8, but there's only the 7 inputs coming in here. right? Because there's a decimal point as well. That's what the D pin input is. There's A, B, C, D, E, F, G for each of the segments, and then there's a decimal point. So what we've got to do is we've got to right, this is what we want conceptually.
I thought I chose the easiest one.
No. Right, so what we really need is we still need to do this, right? But what we've got is, and we still need to have 16 inputs. It's getting from here to here that is the problem. And that's what I'm not sure about just yet. Right? So we've got our 16 inputs and we've got a clock input. We definitely need a clock.
Yeah, because so coming out of the program counter is just a 16-bit, right?
Yeah,
And then
exactly.
we have to find a way to, I guess, convert it to fit this the display.
Exactly.
So,
Right, so our hardware, this is what this circuit is showing me. This is our hardware, right? We've got the number we want to display, and then we've got which digit it's going to be displayed on. I don't know if you've ever looked at it, but if you have an old clock radio with a 7-segment display, if you look at it and you go like that, and you look through your fingers, you'll see it flashing, because they don't display fully all the time. Just about every 7-segment display has to do this. And so what it means is you've basically got to go digit 1, digit 2, digit 3, digit 4. When you've got digit 1 here, you've got to put the data for digit 1 here. When you've got digit 2 here, you've got to put the data for digit 2 here. Because of the timing, what you've also got to do is when you change digit, you've got to blank this out.
yes, so blank out. Oh, yeah, okay.
Right? And once you're definitely on the next digit, then you put the data that you need. Then when you change, you blank it out again. And you've got to do that fast enough so that it looks like they're all displaying like they're displaying, right? Like you expect. But it's because your eye is a lot slower
Yeah,
than
right. That was actually happening.
what's actually happening.
The hardware. Okay.
Okay? So that's what we got to do. And we did this last time I taught this, so it's certainly very much doable.
Okay.
Okay. And I'm okay. I might see about making that example available. See if I can.
So would we just spitballing? Will we need like multiple processors that's acting asynchronously?
I don't know about asynchronous, but certainly not.
Because if it's synchronous, then I guess each digit won't display at the same time if it's going in order, unless we program it so all 4 of the digits display at the same time.
Well, that's the thing. You can't display all 4 of them at the same time. Right? There's only one lot of 7 inputs, so you've got to have them happen one after the other.
But fast enough so it disappears there.
It looks like you're displaying all of them differently, well, at the same time.
And you think the digit before then would still be displayed when the digit after is?
I remember there being a problem with the changeover, and the previous one sort of blurring into the next one
Right,
if you didn't have some sort of a blank interval in between.
Yeah, what other component do we have available? It's like I'm changing my component.
No, you've got this one.
Oh boy.
I think, yeah. it's doable. Let's, I'll see about it.
Just make the source
I will have a look.
available, please.
You're gonna have to explain how it works though. Mohammed, you want to talk through next? Yeah?
Sure.
Let me just go here. And you're just on your branch, yeah?
Yeah, it's
There you go. New code. So what I'm going to do, Vhdl. Got an A register. Okay. Okay, let's go here. Okay, let's go back to it. We've had a submission from Mohammed, and Mohammed, you were given the registers, is that right?
Yep.
So the A register and the D register. Could you talk through your thinking here, and then we'll have a look at the code.
okay. So there's two registers in the CPU, A and D. The A has the 16-bit output coming out of the Mux16 as the input.
Yep.
Right here. It has a carry, clear. That's why we have 1-bit clear input.
And you got the clear input, yep.
And then that's gonna go into the output for that is a 16-bit going into Mux, memory address, and the program counter. Pretty sure
Coming
it's
out
not-
here, yeah.
Yeah, that's it.
And then
So
okay.
that's one of the registers.
Okay, that's the A register. What about D?
So the D has the input coming out of the ALU. That's the 16-bit input. 16-bit output of the ALU is the input.
Right, it's coming around this way. Yeah.
Then the clear input, 1-bit. Then its output is going back into ALU.
Okay. Okay, so I see you've added 3 files. Let's
So
start.
this is pretty much useless because I made the 2 registers. I think the VHD for 2 registers separately. So I don't think this is useful.
You don't think this is useful? Okay.
Well, you have a better idea maybe.
Well, let
you wanna go through this?
talk me through the 3 of them. Let's start with this one.
So this was my initial, just the standard register. This is not related to a project. This is just how a standard register works. So it's gotta have a clock input, a node which we're not using, I'm pretty sure, in this project, or at least I didn't see it. A clear which we're using, and then that's just the output for the mux. That is the input for my register. And then the ALU, that's gonna go into the output for the D register. So, and then
Okay.
you'll see in my attempt at the architecture.
Yep, let's have a look at that.
So, a register is basically just like a flash memory that just stores some bits for some time to send over to the next instruction or the next component. So it's pretty standard for if clear is 1, then ALU is 0. When clear is triggered, there's nothing in the register. But when the clock is rising, then if load is 1, but we're not using it. But this is just a standard, so which is used to us now.
then the ALU, whatever is in the ALU is going into the mux. So it's just transferring data. That's all it's doing. It stores something in it, and then it gives off to the other.
Okay, so you didn't have this information when you did this.
Okay.
Remember what I said earlier today about having an if condition, and I think if you compiled this, you would get a warning about registers being created for the ALU. Okay. The other piece of feedback I'd have about this, let me just check, is right. So it's usually not a good idea to connect signals or constants directly to outputs. And in this particular case, I think the right thing to do is to define a signal that is the value of the register. Okay? So that there's a variable or a signal that's always there. And then instead of resetting the output, you reset the signal. And then outside the process, down here, you just connect that, you wire that signal to the ALU output. Okay, does that make sense?
Makes sense.
So I think that's the right thing to do. But I mean, the logic here looks good. It's just some of the detail that I
As I
think.
said, that's just a standard register, not related to our project.
Okay, so now let's have a look at the other ones that you've done, and let's see how they compare. You go to the A register first, maybe.
Yep. Don't have an architecture for that, but you'll have the entity.
Okay. Talk us through that.
Okay, so the standard is it's the A register. So the clock has the input, clear bit, and then the output for mux is the input for the A register, and it's gonna have one output that's gonna go into all piece. There should be a comment. Yeah, so it's the output for PC program counter, the memory address, and mux 16.
Right. You put that. Just as another comment, I tend to prefer comments in line with the code rather than at the end of the code. When it's at the end of the code, it often either makes the line long, or if you've got your editor set up to wrap, it'll wrap, and it's better to be for this to be all the way over.
Okay. Here's a question for you. Do you want me to make 3 different outputs to be used by 3 different components, or is one good?
No, I've got a. Let's just do the next one. This is the A register. Let's do the other one, and then I'll give you a little bit more feedback, and we can go from there. Let's go up, maybe. There we go. So that was the A register. There's the D register. Let's have a look at that one. Okay, so there's the D register. Talk us through that one.
Okay, so standard clock input, and then the clear bit. The F input is actually the output of ALU. That's just how Emily's code, the variable she used for the output. And then the D register output is the register for the output for my register that's going to be used by whatever is in the comp. I think it's just the mux 16 right now.
Okay. So my feedback is, I think we only really need a register component. I've already given you the feedback about the CPU register. And the feedback on that was make sure that there's a signal to store the value of the register. Once we've got that, then all we need is a generic register. I don't think the operation of the D register is different internally from the operation of the A register. I think they work exactly the same way. Where they're different is we're going to have an instance of the CPU register, which is the A register, and an instance of the CPU register, which is the D register, right? And those instances are going to happen probably in Eric's top-level component, right? And then certainly we need to use better names that match what's on the diagram. Right? Internally to the actual register implementation, I think we're better off just having, like you have in the CPU register implementation, generic names, and maybe not even have ALU, but just have generic, output is probably not the right word, but something more generic to not specify that it's the A register or the D register, or going to the ALU or where it's coming from. Okay? But I mean, again, one of the things I didn't think about when I picked this up is all of the issues with the software engineering piece of communication and naming and stuff like that. Okay. So I'm not quite sure what to do next. We've had Mohammed, Eric, Emily, Kevin, and Matt talk. I would like to get Michael, Fahim, Michael.
I already sent one.
You sent one? Fahim, so do you want to... I've forgotten what you were talking about. Do you... So which one were you doing?
The RAM.
The RAM. Oh, that was Outsiders. Okay, so the RAM is on this side, isn't it? Right? It's being written to at a particular address. Okay, so let's have a look at. And did you submit it to your branch, or did you merge it?
I already merged it.
You merged it? Okay, let's have a look. Let's go to main. Ooh. Oh, that's because that doesn't exist on main. Let's see if we can go there. There we go. View code. And that was 7 days ago. You got that already? Okay, so it must be still on your branch, Fahim. Let's have a look at the branch. Yeah, that's looking more like it. Okay, Fahim, Fahim is developing the writable memory piece, and Fahim, you want to tell us how this works?
By looking to first I look to the diagram of the RAM, how it works, and I come up what boards need to be in the entity of the Vhdl, and I come up with a plot and write enable.
Yep.
And the data n, address n when it's 0, address n when it's true, and enable port when it's false or 0, enable port when it's true, and the data out when it's 0, and data out when it's 1. And it goes to 15 down to 0 as we go to 16-bit unit. And then I use the address as 4-bit, 4 down to 0.
Okay, so there's a lot happening here, and I need to think through. So for a start, just the name here is telling me something about the device. Dual port RAM. If any of you have ever had anything to do with graphics processors, so RAM is memory, right? You read from it, you write to it. Standard RAM, the slower sort usually, has a single address port and maybe not a single data port, but there's only you can only do one thing at a time. You can only either read from the memory or you can write to the memory. What a dual port RAM lets you do is it lets you read and write at the same time. And that's why graphics processors use it, because graphics processors want to do stuff. They want to read memory and display it, and whoever's using the graphics processor wants to write it. And you don't want those two to get in the way of each other. Now, let's just see if we can find the diagram that we were using for the... I don't think I included it here, fortunately. So how am I going to find that? Let's see if... it's under 466 maybe? Maybe there? There we go. It's going to be in one of those, I hope. Ooh, let's... that's that diagram. That's machine language. That's not the right one. I don't know whether we had a good diagram for this, but let's just make that go full screen. Maybe. There we go. Wonder if we can... we can't zoom, unfortunately. Right, so here's a representation. And remember we had two memory components. We had the ROM, where the program was living, and we had the piece that Fahim is looking at, which is the RAM, which is here. And I think, there we go, that this is pretty much what we need. Right? We need a single address line coming in and then a single output coming out. So I don't think we need a dual port. Dual port is interesting to think about, but I think it only needs the single output, okay, for this machine. And then the address, I don't think we need a lot of memory. Remember that the address lines coming out, whether it's the program counter or this one here, right, the memory address, the address lines coming out are both 16-bit. So I would suggest that the RAM needs a 16-bit input address, a 16-bit data output, a clock, and then the read and write indication input, right? Which would be this control line, I think. Right, so here's the 16-bit data going in to the RAM. Here's the read and write, whether we're reading or writing from that RAM. And here's the address to read and write from. So I think that's all we need, just those three things, as well as the clock, because we do need it to be synchronous. Okay, anybody else got something they want to work through? No? Okay, so what I'm going to suggest, actually, Michael Federick, I think talking through what we talked about in the break is probably worthwhile for the whole class. So I might go through that, and feel free to jump in if you want to add something. So Michael is doing the 7-segment display, and Michael tells me he chose that because he thought it would be easy. And unfortunately that's not quite true. Let's explain why. So we want there, we want the hardware documents, we want the schematic diagram. We want to download that PDF. No, we don't want to do it there. Go away. Let's open that downloaded document. You can do it. Come on. There we go. Why doesn't it want me to do full screen? Now let me do full screen. I don't want to do full screen though, do I? Because I can't zoom in on full screen. I can. No, let's get out of there. Sorry, sir. Digital tube. There we go. So this is the way the 7-segment display works on the board, right? We have 8 inputs, even though it's a 7-segment display, there's also a decimal point that we have access to. So it has 8 inputs to turn the LEDs on, right? Trouble is there are only 8 inputs, but there are 4 digits. So what happens is you have to select which digit you're writing to. One thing I want you to try, next time you see, I don't think we have any of the old power supplies. Next time you see a 7-segment display, take your hand, spread your fingers out like that, go like that and look through your fingers at the 7-segment display. You will see the display flickering, because 7-segment displays are almost always done like this. They're never done with 32 inputs for 4 digits. They're always done with 8 inputs and then a select line. Right? They may have an inbuilt mux, so instead of 4 inputs, they may have 2 to do a multiplexer. But here so what you've got to, the way a 7-segment display works is you say, okay, what am I displaying on this digit? Okay, put the data here, turn, and I'm assuming it's this one, turn this line on. Make sure all of these are off. Okay, I'm done. Now, turn this one off, turn the data off, turn this one on, put the data for this second digit on the data line. Right? Then do the same thing and the same thing, then go back and repeat. So what's happening is each number, each digit, is only being flashed on temporarily. Right? And then it goes off. What you're doing if you look at the display and you're making a strobe effect with your fingers. And that allows you to try and capture when each of these digits is off. If you just look at it with your eyes have a slower decay rate. So it looks like they're always on. They're almost certainly not always on. They're nearly always done like this. But because it's done so quickly, you don't notice. I don't know what's wrong with my eyes, but I am quite sensitive to flicker. And I can usually see this happening without doing that. It used to be when these things were cathode ray tube monitors, I had to go around any office that I worked in and change the refresh rate of the monitor from 60 hertz to 75 hertz, because otherwise I get a headache. I could see the flicker if it was about 60 hertz or lower. So I had to, somewhere above 60 hertz, I couldn't see the flicker anymore. So yeah, that's why this particular one is a little complicated, because remember what we're trying to do with this on the CPU. We hadn't decided, but I think a good thing to show here is the program count. Right? So we've got a bit of a problem if that's what we're going to do, because how do we translate from that 16-bit number, which is the program counter, to a select line and 8 or 7 data lines? So let's have a quick think about that, right? So what we're doing, right, is we're going to connect up a box that has that 7-segment display. And just excuse me while I draw all 4 digits. Right? There's the program counter, and one of the things we're connecting the program counter to, remember that program counter is a 16-bit number. Let me just scroll that up a bit so you can see it. Right? And we're going to display the program counter. But what's actually going to happen there, right? So one thing we need is the PC, right, which is going to be a stated logic vector 15 down to 0. We also need the clock, and that's just going to be a stated logic. Now the output is going to be, what's it going to be, Michael?
Standard logic vector 6 down to 0.
So one of them certainly a stated logic vector 6 down to 0.
For the display.
Yep. So let's call that display, or maybe call it digit, maybe. Yeah, because it's a digit. What else is come out?
Which digit, like on the display.
Mhm.
I was thinking, is it possible to, so say we get that 16 bit number, is it possible to select like a character on that 16? So say, for example, the number is like 48FF. Is it possible to select the first, I guess the most left number, and then use that as the first digit to display?
Right, that's what we've got to do. But
then also slow down the clock so the number remains, so we could choose the next number to show that.
right, so we're not there yet. That's what has to happen internally, certainly. Right? And we've got the 16 bits in, we've got the clock. What we need out is the connection to the hardware, one of which is this 6 down to 0, or if we wanted to use the decimal place as well, which we don't, would be 7 down to 0, right? The display. But we need another thing to deal with this. Right? So this is another output we need from our driver. Okay. So I think what we need there is, I'm going to call it a select, maybe digit select would be better, and I think that's also a stated logic vector 3 down to 0, exactly. Okay. So I think that's all we need to start with at the top level, right? Then we need to start, so as we discussed, then we need to start thinking about what happens internally to get from our input to our output. And certainly one thing we need to do is, I'm not going to write Vhdl, I'm just going to write some logic, is we need to track which digit is displayed, right? And that's going to be either, what do they call it? Either PC 0 to 3 or PC 4 to 8, is that right? 4 to 7. Let's make it, let's erase that and make it 4 to 7. 4, 5, 6, 7, 4 bits. Four to 7, or PC 8, 9, 10, 11, or PC 12 to 15. And again, let's just erase that and write it properly. So that's one thing we need to do. And then we need to we just need to really cycle through that and connect. So this one is going to also at the same, so this is going to be what's on the output, but we're also going to have to enable digit 1, and then enable digit 2, enable digit 3, and enable digit 4. Let me see if I can find my code for, looks like I don't have it here. I thought I did. Let's just see if it's up above. There we go, maybe it's in there. Okay, this is not the full thing. Right, so remember this came from the baseball counter. So it's an incomplete implementation of taking a 4-bit number, or in fact an integer in this case, and displaying on the 7th segment display, right? So one thing we have to do in the 7th segment display is this, but extend it for when 5, when 6, when 7, when 8, when 9, when 10, 11, 12, 13, 14, 15. These digits, and again these are, looks like it's all 8 outputs, not just the 7. But what these are doing is this is lighting up the 0, right? This is lighting up the 1. This is lighting up the 2. So we need to do that. And then, let's see if I can find it. I may have not have the full project on this machine. No, this isn't the full project. No, this isn't the full project. Let me see if I can find the full project. I'll look for that a little later. Okay, so we need to do a few things. I would suggest, so what did we have? We had 1, 2, 3, 4, 5. I would suggest we look at those components and get together locally and see what you need to do to improve it. Michael, I'd suggest you working to get that entity statement together, right? To get that done. So what do we have? We have the ALU, we have the top level entity, we have the register, we have the MUX, and Kevin, I've forgotten the program counter, that's right, the program counter. So what I'd suggest is take the feedback I've given you as far as naming and other things are concerned, and update what you have, and let's try and move this forward so that the naming is consistent. I do want to have a little bit of a chat with a group, Emily and neighbours maybe, about what the ALU is going to do. I do want to have another chat with Eric about how that all hangs together. Yeah, if you can take account of my feedback so far on your device. If you don't have a device, try and get one, or just come and see me, and we can get you something to additionally do. But I would suggest working in your groups to try and get those names consistent, and then the next thing we have to do is once we get those entity statements together, we need to start thinking about the architecture. I think Matt is probably done mostly with the MUX, but everything else needs a little bit. I think Mohammed's probably maybe next closest, just because the register. Maybe the program count is pretty good too, but we'll have to. Okay. So let's split up and try and do that. Is that okay? Any questions? Okay. Yeah, go for it.
So I have input touches.
Okay, well, that's okay.
I just don't know what's different from anybody else's.
Right. So,
I just don't get it.
okay. So that's a problem that we should have defined.
Yeah.
Right. What's happening.
So I know we have to have the debounce. I know you gave the debounce. So.
Right. So let's draw a picture. Right. So. And this is what really should be the top level end. We've got the CPU, which is that diagram I've been drawing on, right? This where we've got to. That's everything inside this is the CPU, right? Yeah. Where'd it go? There it is. Right, so there's the CPU. The other thing outside of this is we've got the ROM, and we've got the RAM, and we've got the 7-segment display. Now, what are we doing with the switches? That's the key part, right?
Yeah.
Well, one thing I want to be able to do with the switches is I want to have a clock. Okay, so we can do that. Another thing I want to do with the switches is I want to reset the whole thing. Go back to
So there's
zero.
only 4, correct?
There are only 4
Yeah,
switches,
okay.
that's right. Another thing that I think we need to do is something else. So I think they're the 2 main ones. One of the other things I thought might be good, and it's probably a bridge too far, is maybe we want to change what the display does. Right? So maybe another switch is a mode cycle. Right? So rather than displaying the address of the program counter, display the memory location that the program counter points to. Right? So that would be so what the problem the problem now is how do you get that all to hang together, right? So I think maybe what it would be good for you to do is, even though I think Eric's is called the top level engine, he's really doing the CPU.
Yep.
What it might be good for you to do is to actually do the top level engine. How does everything connect together? Focus on the switches,
Okay.
right? Because what we've got to do with the switches is there's the actual mechanical switch, but then we do want to debounce it, and the debounce code is already there. But then we've got to figure out how to wire that in to what we want to do.
Yeah.
Okay. So what I would suggest is I don't know what to call it, but create another VHDL thing, and that's what we should do. We should define what the entity statement for that is. So what do we need to have to go into that? So this is hard.
Yeah, honestly,
sorry.
I was just confused a little bit. I don't.
Right. So So the clock and the reset. Let's draw the clock in that color, right?
Yep.
The clock has to go in to these things. And the reset, let's just go with that color, I think only goes into the CPU.
Okay.
Okay. Now, so one part of your entity statement, now that's all the same signal, right? That red one is all the same signal.
So there's technically only 2 signals or 2 inputs going to the multiple things.
Right.
Okay.
Except, even though I've drawn this like this,
Yeah, it doesn't go.
there's the actual VHDL code, and let's just make it a lighter color. See if that one works. The actual VHDL code is only this stuff.
Okay.
Right? So anywhere a signal crosses over, we need to be able to talk to hardware, right? This needs to connect to a switch. This needs to connect to a switch.
And then
So
the
you need
image
to,
also
need to connect to the actual display. Right? So this, where I'm heading is, this looks like it has to be an entity with a clock input, which is stood at logic, a reset input, which is stood at logic, and then this is a 4 and this is a 7, right? A digit select stood at logic, and I didn't leave myself enough room, so let's just move it over. Vector 3 down to 0, and then a digit, which is the actual 7 segment thing, which is a stood at logic vector 7, well 6, because there's down to 0. Okay, and I think if you can have a look at that, will, so your particular focus is these things, and you, in the architecture, you're going to have to do this, right? You're going to create a couple of components out of the big bounce switch. But at the moment, we're just trying to get the entity done.
Okay.
I think that's going to do something like, okay?
Let me take a picture.
Yeah, go for it. This is available on the
Sure.
the website as well. So.
Alright, that works. Thank
Okay.
you.
You're welcome.
Try to get something.
Hi, Michael.
One quick question. So, I've been doing all my assignments on my mobile computer, which is at home at the moment, just for help with them. Is there a way that I can just clone everything from the GitHub repository? So, it won't cause an issue.
Well, it will. Yeah, okay. We don't really. And you need to. What do you?
So my main question is to see if I can work on my files from class, even though I have already made a branch and everything.
Provided you pushed it to GitHub, yes, but if you haven't pushed it to GitHub, no. Okay. And the way to do it from here, though, is to use HTTPS.
One other question, so whenever we modify a file, do we need to make a new branch every single time?
No.
Just that?
Just keep your existing branch. I would prefer you work on your own branch and then do a pull request.
And that's any time we modify.
So how's it going?
It's good. We're just talking about like to make sure that they're labeled properly. So like, should I do like R_integer?
I don't care what you do. Just come up with an agreement and make sure we propagate the so make the decision, document the UMD file, and make sure you propagate it as much. I mean, I can propagate it much easier, get the files back together, but get the UMD.
Okay, and just a question somebody wants to talk about
Well, right, so it's a complicated beast, right? And so I think that forgot what you call it, the I output. So I don't think that's an input. I think the instructions are all internal to the ALU.
Okay.
And
So you don't, so since I have like an operator or an integer already for input, you don't think I need an operation input? Okay.
no, the operation is what's coming in through the
Okay.
so I think that is okay. Actually, I'm confused. I'm going to have a look at the diagram again, sorry.
Or no, just from the parent function. But you just listed every single example, like what you did with all these No, just do the last one, the last one, the last one, just
You don't actually have to have it on the more of just a map that is questionable. That would be a little bit more breathing. You should really pay attention
So, I'm so confused, and I apologize. Right, there's the ALU, and it's got to do something based on its inputs. Right, its inputs are coming from the D register, from the MUX, and from the C's at the top. What's confusing me at the moment is where it's being told what to do. Where is that coming from?
That's why I was confused, because like, for the R and S, that gives me an integer, like, whether it's R plus S or R minus S or S minus R, etc.
Right.
But then in order to implement that, I would need an operation function, like whether it's and or
Right.
whatever. So that's
Right.
why I put it on.
Yep. No, I see that. I see that a bit more clearly. I'm still not sure whether it's the right thing to do, but I see precisely what he did. It's the right thing to do.
And then also like the input that I use the variable like CE, I was thinking it's coming from basically if it's higher or low, kind of it's 0 or 1, I think.
Yeah.
And then obviously I can block it. And then all my flags are the outputs.
So I was thinking that those three tables with what the instructions do, I was thinking that happens in the output. I think I'm wrong.
I'm just thinking like what I learned in microcomputers for the ALU could apply to this, so I don't know if it applies to what we're doing here, but just how
But
I understand how
I
the
think
ALU
you're
works.
closer to the market than I am, right? So I think that's good. What I'm starting to believe now is maybe those three tables are happening in whatever entity is capturing this, which I think is probably Eric's entity. So
Yep, extra work for you to say.
I was having the discussion with the ALU with Emily, right? And I think I'm wrong in that I was thinking all of those instruction information, those three tables, which is the next slide, is happening in the ALU. I don't think it's happening in the ALU now. I think it's happening in your piece, right? So I think what's going to happen now, Eric, I don't know. I mean, this is the first time I've done this, so I think now that the way Emily did it with that eye with just a subset of bits is probably closer to the mark, right? Because the ALU only needs to know what arithmetic operation it has to carry out, and those bits are enough information for it to do its job. But there are other bits. There's the jump information stuff, which has to hit the program counter, and there's what's the other one? Or the where the data's coming from, the destination and source stuff, right? Which the ALU doesn't have any control of. So I think that's what's happening. So I think what Eric, you're going to have to think about as far as the architecture piece is how to think. And we're all doing this together, right? It's a group project. Sorry? No, well you can't, right? You've got to have input from other people. Right? So yeah, I think that's the right thing. Any questions? I don't know what you've got to do yet, but let's figure it out. But well, one thing you've got to do is you've got to have an input which is the instruction input, right? And you've got to feed some of those bits to the ALU. So there's a connection that's got to be made there.
Doesn't it just go to the box first?
Right, it goes to the mux.
I
Right.
think what the problem was is that those charts that he showed were more than just the arithmetic part of like what the ALU is supposed to do. So he was thinking that the ALU provides all of that on the table and it doesn't.
Yeah.
So I can help you like with the other ones that he got were in the ALU that are on the table, but like he said, like kind of like what we do in microcomputers, like in the program counter, then it starts to the stack pointer, that whole thing, that's not the ALU, but it's still in that table that shows that's what happened in the ALU. But it's more like that's just the function that has to occur instead of like a specific component doing it. So I can help like explain that and show you. Yeah.
I think following you.
Like he's trying to say the ALU is doing all of its data processing. It doesn't do that. It just strictly does like add, subtract, and multiply. I just take it from microcomputers. That's how I know. That's the only reason why this makes sense to me. Just like the jump instructions, the ALU doesn't do that. That's all like program counter, like stack pointer, big stuff. Like so that's what your entity has to
Yeah,
that's like
the
the
same
missing component.
problem I had with Michael Gallagher, right?
So
What's the connectivity?
I know you can.
And where did I put it? Let's scroll down. This is the wrong one. Why am I here? I think this is the wrong one. How did I get here? Yeah, I'm at the wrong one. How did I get here? I should be here. There we go. That's today's stuff.
Like, three of them do the same thing, but not the same thing. No, it's true, like, one of them said,
Where did I
like,
put it?
less
I
than,
thought
or
I
one
had
said,
a
oh, no, less than,
diagram that I drew for... There we go.
they're all mean the same thing, they just do one thing.
Right, so you should probably talk with Michael Gallagher in the back left there. Right, so the other thing, the thing that's missing from this, that I probably shouldn't have missed,
Yeah, it's more like he just read off his
is you've got
and mostly in the lab we're writing code.
4 LEDs, right? So there's got to be somewhere coming out of. So this grey piece is this is the top level entity, the real top level entity, and all of the things that cross into here are hardware signals on the board, right? And the ones that Michael was interested in were the switches, right? So, and I said there should be a clock which has got to drive everything, and there's a reset switch.
So I need to have a clock and reset.
That's how what? I don't
Well,
that's kind of like how it feels to me. It's like, okay, well,
Because I'm only doing outputs.
right, so let's think about what the outputs are. So
that was like the first thing you did. The only thing
I think the main thing we've got to do though
like once you
is, let's get a different colour.
but it's like you jump, you compare something
We've got to figure out what's being displayed.
yeah, but like you jump to the late one, what the value change, okay. So then
And there's a few things we could display. I think a bridge too far with what I was suggesting with Michael is to have a button that cycles the mode of what this display shows. Instead of showing the program counter, we could get it to display the memory location of the current program counter.
instead of like, and I think we're
It's not ideal, but I think what we could use these LEDs for is to display the top 4 bits of the memory at the program counter. Okay? So what does that mean?
Get input from the program counter.
Sorry?
I need to get the input from the program counter.
And then, well, so the program counter is going to be connected to the ROM, right? This line here is the output from the CPU, which is the program counter. And the output is the instruction. So this is the thing you've got to. So really, it's just a connection that you've got to make sure you have. Okay.
From the ROM.
From the on the output, you need to take the output of the ROM and display the top 4 bits of that.
So the top 4 bits then is like 0 to 3 or
15 down to 12. 15, 14, 13, 12. Okay. The reason I say let's have a look at the instructions, right? So, maybe not. I tell a lie. But I was thinking. But the only information is the A bit, right? So
and if you want to do electrical stuff,
maybe
you do that. I think we have too much like crazy stuff like
A bit and those 3, or the A bit and those 3.
What is the point of the times.
So A is that standard
I
three.
won't use that class.
Literally, that's all, the only control
So
is,
I would say this is 15, 14, 13, 12.
Okay, so 12.
12.
That's literally,
Okay, well, I
that's
took
literally
that
not.
class in
2, 1,
A6,
0
so I
maybe.
learned that one.
That's literally
But-
something else. That's another one.
Okay.
That's not something.
But I would suggest that
We could include that in other class, like, and.
you should work
you know,
with
like,
Michael
I don't
to.
know how you guys.
Let's just go back and have a chat with Michael.
I took all the networks so early, and now it's like all I'm doing is electrical based stuff. Like I have analog, freaking electronic automation, like it's all circuit based. So it's like, but it's like if you should, like, you should be able to pick your path eventually if you want to do network and server stuff. And I said, and honestly, for a computer engineering and too many networking classes, I said that there's a networking major here, and that's, if you want to do that, that's what you should go. Like, this is not a major at all. Like, we don't need to take 249, 249, 339. And it's interesting because they had alumni there that talked about the program when they were in the program, and some of them like were graduates in 2015 or 2016, and they talk about how like what they took in the major and how like much it's changed. Like, and they had more like software. It was more like software engineering and electrical based. That's all it was. They didn't have any networking classes. The major changed so much since just like 4 years ago. Yeah, it was like they said they never had like one networking class. Or they talked about that 339 class. Henry taught it. I think Kenneth teaches it now, but they didn't have any of that. Like it was just coding or electrical stuff. That was it. They didn't have that hardware architecture class.
You get shown something, and then the next semester you forget about it and start something like
And one of the alumni said that they should make microcomputers to a requirement.
Right.
And make the microcomputers we're in now, the 200 level class, which is like intro to how a computer works, like coding. And that's what we were just talking about. Because they just threw you into CS1, like here's Java, go code this, and you don't know how to code. Like that's the first class I took. I'm like, what the hell is this? And the professor sucked nonetheless. So, no, I had her husband, but I had her for CS2.
And then after that, you're just like, I'm
But
never
then
going
if
to
you
use
take
this again.
advanced microcomputers, like a little later on, it's more effective.
It was just so big that.
And they also talked about how we don't have enough project management courses. Like they just added 6 Sigma as a direct electrical, which is like project management and operation. Like I took that one. Yeah, they said that. So there was 10 AVET accreditation people, 4 alumni, me, and one other CET student.
Yeah, well, I ran through CC 439 and it gave me all this stuff we built this
Yeah, there was 2 professors. One that I never even seen before. He's the
The
guy
only
who
thing that's
first.
somewhat consistent, not really, is the electrical stuff. Because every semester we end up having some of that stuff, but still don't.
Yeah, he's on the board. Him and Rose are on the board. Yeah, well, I know where
Zygos showed some of it.
the more political side of this figure.
Especially if you're not going to use it, if you ask and actually reference it.
Right, so I don't know whether you're doing the RAM. I don't know whether the RAM needs to be dual ported.
Because when I do my own logic code, it's gonna come from the user logic code, it's gonna come from the memory RAM. All this information is gonna as input. and the RAM is gonna send those information back as output to the user logic. So I have to do this, the first code I did. You know, enable, address data in, plug that out. So and I come up with this code.
Right.
But I don't try it yet, it's gonna work or not, I don't run it yet.
But the trouble with this is, let's just see, this is only saying out. Let's see if we've got a RAM in.
No, that's for the bonus.
No, but it was in replacement for, we're doing it in person, but since it was on my own, we're doing it implemented.
Yeah, you might be right. Right, so you've got a read write, and you've got, this is the data going into the memory.
Right, you're trying to, and then the end,
This is the data coming out of the memory. And there's the address. So there's only one address, but yeah, you've got an output, and you've got a 16-bit output, and you've got a 16-bit input.
yeah.
Yep. Yeah, so that looks good. Yeah, you can rewrite. Yeah, that looks good. Okay, yeah, good.
I had to take it on myself to walk through the full class, so I could really
Not in terms of jobs, general hospitals.
How did you do that? I was taking 3 classes and
At one point, COVID did not happen. I think it was at my dad's so it's not like when I started programming as a sophomore, I started doing it and I was like, I told the guy like, I don't know how to go with this. But I didn't know.
So if I could just have everybody's attention, we've got no, it is not. We've got a naming convention that's the back row is starting to come up with. So we need to agree. A current names we should use are clock and clear. Okay? Not CLK, not CL, not CLR. That's what I've got so far for a naming convention. I haven't.
What, clear's like reset?
Well, that's the question. What is that a? Should that be reset? That's a good question. I know the register probably.
Yeah, let's make it reset.
Yeah, probably want to reset. Yeah.
That makes more sense.
I think I agree. Mohammed, are you okay with that? Okay, so let's go with reset. I think that's a.
Because I had it like that.
That's okay. No, that's good. Does anybody else have something we should add to our naming convention?
Use underscores.
No underscores.
Can we get a vote?
Okay, let's have a vote. Everybody who thinks we should use underscores.
Thank you. I'll give you guys breakfast.
We should use, so we've got, hold them up, we've got 3, 4, 5. Everybody who thinks, what's the other option? We should use camel case?
Right, y'all don't know what's called
No,
then.
no underscores?
No, that's the thing.
So, I'm,
Force
All camels.
overruled.
so who thinks we should not use underscores? So there's 4.
I'm only saying that because the schematic you uploaded doesn't have underscore, as I am in capital M.
I know, and I disagree with that. So, so I am suggesting you use underscores. I am not going to make it part of the naming convention. If you can get away with just having a single word variable name, that is better than having a 2-word variable name. Okay?
I have a serious question.
No, you don't, Michael. Go ahead. No serious question starts with I have a serious question.
I don't have a serious question.
Okay, go for it.
But so we have about 2 weeks left of school, and that's including so next week there's no class, right? Thanksgiving, which means we have one more class session.
One more class.
So what are your expectations within that one class session?
I don't know. What I'm hoping is,
Based off what we're doing now and how far we got today, right?
I think we're about probably 3 class sessions away from complete. 3 to 4 would be my guess. So we're not going to complete, right? So I want to get as far as we can. And in the next class session, I'll spend at the end of the class session, I'll spend about 45 minutes summing up and saying how far we've gone.
Because I'll be honest with you, I don't even think we're going to be able to get the architecture finished within the next class. Not everyone's architecture.
No, I don't think so. I think you're right.
We should run through it together.
Yeah,
Next
exactly.
course, we should just, or next class, we should.
No, you're right the first time. That's cool.
No, I'm not taking.
You're all coming back next.
Not for us, not for us. This is the next cohort.
Yeah, next year we can leave. We can leave
Next
for that.
cohort. Next cohort.
Yeah, no, I don't expect we're going to finish it, but I want to get as far as we can. And some components are going. I think the register is just about done. The MUX is done. I think modular will be talked about. I think the ALU could get done. What I think is going to be missing is I don't think we're going to get I think effectively Eric's component, which is going to implement a lot of the instructions. I don't think we're necessarily going to get that far. Okay. But what I will do between now and next class is I'll try and scope out something that gets us something on the board, that we can actually deploy to the FPGA. It's not going to be as good as, so for example, and the way you do that is you downscope. Right, so here's our full scope of the instructions, and the way you deal with it is you downscope. So let's forget about jump instructions. Right? We just run through the program memory, and we start at the beginning. Right? So it just cycles through. So we don't do jump instructions. We probably want to do one at least of the destinations, maybe hard-coded. And I think we might want to do some of these, maybe not all. So let me work on downscoping this so we can get it working. Okay. What's the time? The reason I came up here in the first place was naming conventions. I only had the 2. We haven't got, and I think we've said suggest underscores, but like I said, use your best effort to only use a single word.
So, capital for
So
organization, word.
See, VHDL is not case sensitive, right? So I tend to prefer just everything in lowercase because of that. Normally I work with camel case stuff, so no, I don't want to drag that in. Let's just try and keep everything lowercase and go with that. I think it's okay to have stuff like ALU capitalized, or even PC. I think that's okay capitalized when it's an in-project acronym. Like it's the program counter, we know that. We know the ALU. I think it's okay to keep those, but other than that, I would tend to. So that's the other thing I would suggest is suggest lowercase. Okay, I'm going to go back. Sorry, Mohammed, I stopped talking because of the. So what did you actually want?
What were we talking about? Yeah, what were we talking about?
Right, so then we need to actually implement.
So I was asking Mike earlier, before you showed up, working up, do you think he'll be able to get the capstone by the last class? You said yeah.
We should, yeah, I think we should be able to. Quality would be great. Getting the pictures look nicer would be something we talked about. I don't know if he explained to you the whole situation we were having.
You studied,
But we don't have a flash.
I thought you came up with an idea to use the LED strips.
They we were having a really hard time connecting them to the live. We didn't have. Actually, honestly, I really don't know why we're not using it. Because when I hooked them up, I hooked them up to a USB cable and I spliced the wires together. And I plugged it in and it started to get hot. And I was talking to Broderick and he was like, yeah, you're going to have to put like a resistor on the wire and that should work. So I made Anthony a resistor to see how it works. So yeah, if we tried it and it didn't work, I don't know.
I was thinking the device that I'm using to receive the signal from my phone, to translate that over to the microcontroller. It also has a camera. I was just thinking just now that you could have easily just used that one device to take a picture, to retrieve the picture, store it in the data. And the device also has a flash because it has a camera. I was thinking that it would have been perfect. You would have to obviously find the code and everything yourself. But in theory, it would work because it already has a flash that is right.
You have it?
The device? What is this? But you're so big, you might, because there's a few steps that you have to keep going to get it to work. You have to remember these steps every time you upload code.
Yeah. That's okay.
Unless you can code our mobile application, then that's fine.
I don't know what I'm going to do.
Because I can code in C and C++.
Honestly, I don't want to put it on.
Not true.
Yeah, it's just the board. It's just the board.
It runs on Wi-Fi, so I can connect all three, like my motor and my tablet to it.
So you're
Try running And then, like, also it has touchless sensors, which I need sensors to go onto LEDs. But I have no help.
Well, first of all, just having the component statement, right? So you're going to have to pull, for example, Muhammad's
So ultimately,
I got a lot of help from that.
Let's just
What
put
they're
the
looking for
thing
for,
on
like,
the
component.
board. Right, so you're going to have to
Yeah,
pull
so like
in
the
Max,
but they would
Mux
buy,
as a
I would be
component,
able
Two
to
times,
two
right?
instances.
Two instances.
Right, so there's two. When you do that, you've got to do two things. One of them is you've just got to have the component state before the or the beginning of the before the begin statement in the architecture.
Okay.
Right, so that you instantiate.
Well, just everything.
So sorry, not so that you instantiate, so that you know that it exists. Then you need to instantiate two of them.
Yeah.
Right, I don't know what you call it, but give it a nice name.
Yeah, so basically like the
Instruction mux and ALU mux. I don't know. Or A register mux and ALU mux.
Okay.
So they want to make it
Right.
digital.
And the way you do that is you use the name,
like
colon,
arrow keys, down, left, right, forward, backward. There's emergency
and then
stop
the
button. And those are two
type
types
of
of
component that
authentication.
you've
There'll be
defined
regular
first,
operator,
and then the
that'll be
port
able
map
to
statement
And
that
then there'll be one
Yeah.
takes
like
the inputs
inspector
to
or tester.
any signals in
It'll be
your.
automated, so when you
Okay.
press the button, the bird
Okay.
will go out by itself.
So you're going to need
So they can test
mux
it.
as a component, a register as a component, a program counter as a
The
component,
bridge, when it hits
and
the
the
airplane,
ALU.
LED
What about the
has
D
to go
register?
off saying, okay. Yep.
There's only one register component, so you only need
So like I'm gonna use.
Oh, we're just talking about component.
the
Okay.
component
I see what
state,
you mean.
right? Then when you get to instantiation, then you need two registers, A register and D register. You need two muxes. You only need one ALU. You only need one PC.
So it wouldn't be the A and D register wouldn't be two separate components since they have different inputs and outputs.
Yeah, they will be two separate instantiations of
Yeah.
the same register component.
So what would the
Yeah.
so the entity statements are they technically the same for register? For both
Yeah,
registers?
yeah. They should be exactly the same, right? Because
Well, they don't have the same input. That's what's confusing me.
well, they don't have the same input, so the signals are different. But this is 16 bits. This is 16 bits. This is 16
Right.
bits. This is 16 bits.
So in the entity statement, they would need to be in like Muhammad's entity statement for the registers. They're not going to be the same because the D register's inputs coming from the ALU.
Right, but the D register itself doesn't know where its inputs are coming from. It just knows it's getting 16 inputs.
Gotcha. Okay.
Right?
Yep.
You're going to have to tell it your A register inputs are coming from here and your D register inputs are coming from somewhere else.
Okay. So I would say the D register inputs are coming from the ALU, and the A register inputs are coming from the MUX.
Right, and so another thing you're going to have to think about is it might make sense to define a signal called ALU output.
Yeah.
And probably not deregister output. I don't know. Anytime there's something like this, I suggest you might need a signal to do it because it's going to go to multiple places,
Yeah.
and you may be better off.
A motor driver actually.
Okay.
Yeah.
Yeah, I mean, sounds like a
motor
lot.
driver that's compatible with it.
So what I'd suggest to get done before next time we get together is just make sure that you have pulled in all the components from everybody else's entities.
Okay.
And I think we could almost do that because I think maybe Emily's is okay. We'll have to review.
Yeah, I know Matt's is okay.
But Matt's is fine. I think Mohammed's just about done with his rejig of the register, so Mohammed's will be fine.
Okay.
And
So do you get component statements done for?
get the component statements done for next time, and then we'll see how we go from there. And if you could get them done sooner rather than later, just as a first cut, because I want to get in there and try and move us along before next time. Okay, and I'll ping you if I do any updates or change stuff.
Yeah, sounds good.
Okay. Great.
But it must be the hardware
Yep.
related, like he's really
Yes.
good with telling me like this is gonna
So
happen,
the
this
idea
happens,
is
like,
that
but I don't know how it's gonna do yet.
let me draw some. So the idea is,
Yeah, but see, that's like when he specializes in like.
let's get
for me,
go down here.
it's, like,
Get some blanks, right? So what happens is you do a commit, right? And this is main. Call this main, right? And then
He's way more advanced. I know C and C++.
David does their own branch, and main continues on, and then you do another couple of commits. Now,
But the thing is,
the trouble is you can't just
I can get Python package. So if I get
commit
Python
straight onto there
package,
because of these extra changes,
then it might
right?
be
There's
easier for
more
me.
change.
Just because
So what
I
you've
don't
got to
know
do
Python. I don't know how to connect
is,
devices with C and
in order
C++.
to
I know
do the
how to code in
update
Python.
properly, first of all, you're going to have to pull the changes from main onto your branch, which means that you will get everybody else's files. Whoever else has been has done a pull request onto main. Okay. Normally that's okay because you're using different files and it's not a big deal. So once you've done that pull request, then you can push onto main, and your changes get onto main as well.
So that's what I'm doing.
Yep, that's basically what's happening.
And can you also look at my so I'm doing the program memory.
Yep.
I'm with the kid that sits behind me in microcomputers.
Just click here. So you can call the address, and then the instruction. Yep, that looks right.
So I have the ROM inside the.
Yep, exactly. So now what you've got to do is you've got to take that and figure out how to read out from an instruction memory. So you've got to probably have an array of bytes of some description, and when you get that instruction, push it out to the other.
Okay.
I would suggest because you've got 16 bits. I would suggest not making a full 16-bit because that's 65,000 entries, and I don't want to see 65,000 entries in it. I would suggest making maybe a 5-bit memory, so you have 32 entries.
Okay.
And then talk to me about between now and next class, so about 2 weeks' time, about what values should go in there. So let's try and work on a program 32 steps long that the CPU should execute. And what we'll do is we'll forget about what I'm thinking you should do is just write a counter, right? So that'll be the test program, or it'll be a program that we want to run on the made-up CPU. Okay. Father?
What is
This school now.
Because you're just going straight to the hardware, I don't think people want software.
This is a new school. A new major, new major.
Yeah, it's a
School, so
Why are they locking them around this building?
So what's the, yeah, I know, I'm not sure what the between
How much do they have? They got parents, like, if you're a parent,
Sorry?
this is the.
White wall, that was it.
I just can't believe we have all the classes of
I think that's all you're gonna do.
So, I'm going to put in the.
Or you get the stupid verification code, like in class
Oh,
rather than
wow.
here. Yeah, it's so aggravating, I hate that. Oh, yeah, there's so many night classes.
I can't wait to I'm trying, every class,
Hey, did you do better on
amount
test
of work,
too?
every class is trying.
Nice. I don't know out of 70, but I got an 81 like overall grade. So yes, much better.
At this point, I'm just chilling. I don't need to
Yeah,
study for
I
the
mean even some of the kids that like got 30s and 40s, they got like 70s on the second one. So analog.
That's the project.
Roger teaches analog The thing is, like, the beginning of the semester, he taught, like, that, and then he started going into the transistor stuff, and it was really good. Like, everyone did really good on the second exam. And now we're in, like, AC transistor, and it's going down.
I have another question about the when we went to the in the beginning of the semester I was a little confused with the CET activity. Yep. So week 3 real lecture I missed only like some of the answers. Very low
First
percentage.
exam?
Are you able like
First
to
exam, I got
Yeah, just send me an email.
I couldn't give you 1.2.
Parts class?
Second exam, I got an 80.
And parts class?
First one, I got a C.
How many of us failed all those exams?
Or I probably failed in the third.
That's what he did, he hurt everybody.
So I've been talking to Roderick this morning. He's teaching analog 1 next semester.
Two,
Thank God,
analog 2.
he's doing
Oh my
two.
God.
Analog 2, yeah.
They forced me to go to community college for analog 2 for a semester. They
Yeah, I
wouldn't
have for
teach
analog 2.
Oh, really?
Yeah, no,
They
a lot of
wouldn't
people
teach it.
signed up, right?
Yeah, they had like 4 people that wouldn't teach it. So
Well, you look at the reviews on Ray My Professor,
Yeah,
it's a little bit scary.
Take that 1.5.
So one of the things he's been going through is how to teach it, right?
Yeah, he says in our class we have with him on Mondays and Wednesdays, he's like, all of you in analog, there's like a bunch of us in that class that are in analog 1 right now. He's like, I'm just gonna ask you guys what you know and what you don't know, and we're just gonna go back over it. He's like, I never taught it before, but
don't teach anything.
I think he'll do a good job with analog 2 though.
Yeah, no, I think he will. But he's so.
It just sucks he has to fill such a big gap, you know? Like they don't start him with the basic one, but
Yeah, I mean that's something we've got to figure out. And well, several people here, the capstone students know that so how to say this?
We had a little meeting. Rented
So there was a staff meeting a while ago, and
Just let it out.
It's okay. We won't judge. It's okay.
We had the same opinions.
Yeah, I know.
I can close the door.
oh yeah, they're doing tours right now.
So there was a report out about a meeting with President Tor, right? And it sounded from the report out that it was all this airy-fairy problems that had nothing to do with that. And I knew explicitly on that particular issue that it was very definitely about our department, right, with the CET program. So I said as much. And so I had a meeting with the Dean on Friday. And I haven't put in any names either of students or faculty, but I know 5 students who are impacted at least, and I know at least 2 faculty that could do with improvement. And one of the things I personally am doing is trying to let the student body know how to complain and who to complain to. Because it's not clear. And there's various avenues. I mean, first and foremost, the person you should complain to is the professor. Right? Sometimes that works, sometimes it doesn't. If it doesn't, who do you go? Well, you go to the head of the program, either the program director or the head of the chair of the department, the program. Right? Again, sometimes that works, sometimes it doesn't. What do you do then? Well, then you go to the dean or the dean's office, an associate dean in the dean's office. Sometimes that works, sometimes it doesn't. What do you do then? Well, then there's an office of the, I really hate the word, but ombudsperson, right? And the person who is head of that is, I haven't actually met them. Apparently they're really good. That's one person you can go to after. Another person is the Vice President of Diversity and Inclusion, Equity. I think it's Stacey Miller. I think she only came on board in January and I haven't.
You have to go through all that just to be heard. Like, damn.
That I know.
Oh my
shouldn't.
gosh. I
It
don't
should
even
not
remember
be
like
this
the first
bad.
person you said to go to.
It should be the professor. Right?
Yeah.
It should be fixed there.
Well, you and Broderick do a good job of listening to us, so.
But yeah.
You know, it's funny, Professor. I had a former student do all that. Went through teacher, dean, that department.
I got to speak at that AVET accreditation thing. That was a very interesting experience for me to hear from a few professors that are on the committee advisory board and also from alumni to hear their opinion on the program from what they had and what we have now. And then to be able to express it in my opinion. It was very interesting.
Yeah. No, I don't know what the right thing to do is, but I do know they're doing the wrong thing.
Call Channel 6 News, tell them. Come to
Well,
CCS
so
meeting.
I
Observe this one's discussed past.
one thing I know that happened is one of our graduates decided that they'd had enough. They'd gone through all of those channels and nothing had happened. So they went and got a meeting with the President Toro.
Yeah.
And that is why that report out in the meeting that started me off on my rant happened, because President Toro had been complaining to directly.
That's probably the same person.
Yeah, it is. Yeah. So, right? It shouldn't have to go outside the
The school just to
Yeah.
say this professor sucks.
Like the department can't handle it.
And it's the same professor we're all talking about.
Yeah, I know.
So, anyway,
You see that email they sent out with the AVET survey?
Yeah,
It asks for your student ID, full name, all this stuff.
I filled that out. I go, give me more class times. It's
I want
unfair that there's one class time for
I
every
want
class.
nothing to do with that. If I'm going to say something, I don't want my name in there. I'm all set.
right.
Every person says.
Yeah, I don't care.
I don't care.
No, because after December 10th or whatever, I'm done. I'm out. I want nothing to do with this one.
December 12th.
The 12th?
That's when microprojectors finals.
So one thing that happened when
Actually,
I
final project.
No, the test. Don't talk about pineapple.
Literally every class.
One thing that happened when I was a student, I'm trying to remember the name. We had the same problem that Eric had, right? We didn't want to put our names to stuff. So what we did is we made up a student. And we made up a student number.
Oh, nice.
And everybody used the same one.
That's
awesome.
a good idea.
Right? So you don't want, sometimes you don't want stuff tracked back, right? You do want to make the information, you want to raise the issue, but you want some way of
Who knows what they're going to do with your name?
Well, it's like you get punished for speaking up because you're probably like one of like very few that speak up with your name so they listen to you.
Well, that shouldn't happen.
Yeah.
It
That's
does,
why I
it
got
does.
picked to speak with the accreditation thing. I already know. She emailed me like, oh, this professor came to me saying you're complaining about him to his face, and I have a meeting with her, and blah, blah, blah. So yeah, it was long.
Complaints.
Yes, because I asked him to teach better. Like, I'm not understanding.
How
It was
can
bad
I
online. I can't imagine it in person. I can't imagine.
Because I asked him after class, like, can I come to your office hours?
No, he said no.
He said no, because he's busy during the time. I said, so why you have office hours then?
You know why he's busy? Because he doesn't grade anything until the last day.
So I'm like, listen, I still have to take, at first, before Broderick was teaching analog 2, I'm thinking like, that Park was going to teach analog 2, you know? So I wanted to understand analog 1 with him if I have to take analog 2. So I asked to go to his office hours and he doesn't want me.
We had a Discord, right? And we all found each other through Discord. We took his class online. And me and Michael were talking, like, all right, how do you think you done the test? Well, I failed. And we asked somebody else, how do you think you did? Oh, I failed. There's only 10 people, and like 8 of us failed.
And we still ended up
Like,
with B.
not one test, but like every single one.
Still ended up with
So we all ended up with like A's.
Yeah, it's stupid.
Doesn't make sense.
Well, that's absolutely nothing.
Analog, I'm just analog 2 at the community college is a joke. It's like the most, it's literally analog 1, way easier than analog 1. Way easier.
Do you understand anything?
It's so easy. And so all you do is make circuits, and then I think it's called pi circuit, and you just take the values and that's all it is.
All we do is,
Unfortunately, broken code make me try to understand.
well, let me show you what our day is. We show up to class, we pull up the lecture at the book company goes, start going through it. We go to the example in the book that has like 2 lines of math. You rewrite it, then you rewrite it again, but change one value.
Yeah.
And then we move on to the side and just repeat that, and then have a nice day.
He takes attendance twice just to make sure.
Just to make sure you're there.
Wait, next class, who's at the top?
But it was brutal. In analog 1, it was brutal because no one was talking to him. Because no one knew what was going on. No one wanted to
Answer any
answer any
questions.
questions. So
He
would
wanted us
ask.
to have he wanted us to turn our webcam on every class. No one did. Everyone's
Pull
like,
that
no.
all over again in person.
You don't have, yeah.
Nobody what?
No, at first he's like, yeah, can you guys all turn your webcams on? And we're like, no.
And then he,
I was like,
no one answered. He was sitting there like 20 minutes, no one talking. And we finally realized, okay, let's answer the questions. Well, when we got to analog 2, you know Hobby, right?
So he teaches a lot of classes.
Analog 2,
He's
and then Hobby starts asking questions the first day. I messaged Hobby, I said, Hobby, don't ask any questions because you won't get the answer. Just go around there or something. Don't bother. Pull out. And Hobby was like, I want to ask because I want to learn. I was like, no, don't answer anything.
So,
come to your office hours.
what I'd say is,
There was an exam coming up, I want to understand.
if you're worried, wait until you graduate, they complain.
I personally don't. They're not going to stop my degree in 2 weeks.
Okay, well, your times are listed here, so when are you available to speak?
I would
It's like, well,
suggest
you
that
can just
the
email me,
interim dean,
back
Jerry Jarrett,
I'm
is
like,
very changed.
so I just went up, I said, so where's my money go? Because clearly you
If that
shouldn't be getting
is
any
too close to home,
So that's why I
go
had to speak
through
at
the
the thing,
office
too,
person.
that I had to
The
be
CCS has got to be used by an office person. And get arranged. That's what I would say.
And I told the dean,
Some do
I said to you,
there's a push at the moment, and the more pressure that there
like,
is.
he was just saying, everybody passes with a BA,
Oh.
maybe someone with C, but everybody passes, you don't fail, so if everybody fails, just pass with this is not fired because he's showing that the kids are passing, like,
Okay, so let's
and she's like,
do
oh,
this.
we're working on that, we don't really know yet, like, this was like 3 hours. I had to go back and forth between like me and him and this accreditation meeting, and like it was all on Monday.
Just for an example, I don't even remember what we were going over, but this is the page of notes that's drawn up.
Then I had a meeting with the
Can you tell me
myself,
one
and then
thing?
I had that 2-hour accreditation meeting with the whole board. There was like 12 advising members, 2 professors who were alumni, me, and some guy named Rich.
Oh, it's an MRI.
You actually can't sue soon
Yeah,
because it's a
on
public
Monday.
university and they're, I
And
looked
then
it
I had to
up,
go
like,
to his
I
class
tell them.
nonetheless, after all that. After all that,
My drawing
You
sucks.
can't sue what that meant. So my drawing
After I
sucks.
went through all that.
And I
It's owned by the state, already like exclusive.
Well, Monday was fine because we just did the lab, so.
You probably said
Wednesday,
an
we started
exclusive like
chapter
contract
6.
against lawsuits.
He lost his.
So pretty much like not know how to
It was some version of transistor, but now it was whole set of equations, but you use the DC model, and then you switch to AC.
I don't think we are at the moment.
Okay, so we've been derailed.
Yeah, we're
Thank you
done.
for the conversation.
No, thank
I
you.
do want you to do something between now and next time. It's going to be very different for everybody because everything's a little different. What I want you to do is communicate with each other about what's happening. I think the key touch points, Eric is going to be one key touch point. I think Michael Gallagher is going to be another. I've asked Michael to look at the overall thing, right? The real top level entities. So Eric is doing.
Yeah, so everything.
Eric is doing. Eric is putting together basically the CPU, which is this thing.
Okay, so you don't have much.
Wait, what is it?
I did that far.
So you have to put this together, right? What this has to connect to. Where's it going? I did have a picture there somewhere. Where did it go? Where did I put it?
Really bad in the second one?
Sorry, let me just zoom out and then zoom in again.
I have like an hour and stuff.
Especially because it's not, it uses so much stuff that it's,
I just didn't study. I just didn't.
There we go.
Yeah, I had a particular.
See that one?
It took everyone 4 hours.
Because we had to write everything. She's like,
And then she sent us an email one second, she's like, let me just tell you.
Okay, so Eric, that's your block. That is what your entity is doing.
Okay.
Right? That's all the stuff on that other diagram.
Right.
The trouble is there's stuff outside of that that still needs to be connected. So there's the ROM, and there's the RAM, there's the hardware of the 7-segment display, there's the hardware of the LEDs. It's that overall thing that I've asked Michael to have. Okay, does that make sense? Yeah? So I'm going to put up another submission. I want you to submit something into GitHub. If you don't know what to submit into GitHub, talk to me via Discord or email or what have you. And let's get some motion forward. I'm going to put some legwork in between now and our next class to try and get something working. What I'm aiming for is to have 32 instructions in our ROM. I'm aiming for a simple program. I'm thinking just a counter, and that counter will, maybe that's what we should put out here, right? Maybe just a 4-bit counter would be something good to try and implement. I think we should be able to do that in 32 instructions. I don't know. Let me try and write the program. I forgot to talk about the NAND to Tetris people actually have a little Java program that compiles the assembly language. I really hate when it does that. So there it is. The NAND to Tetris people have a little compiler or assembler that takes the assembly language and turns it into machine code. And it's this machine code that's going to be in that ROM. I'm going to write that. I'm going to try and write that as a 4-bit counter. And then once I get my head around what we're doing there, then I'll be able to tell Michael how to connect up the LEDs, for example. I think the program counter just goes to the 7-segment display. Michael, I owe you more detail on what was done previously on the 7-segment display. Don't let me forget that. And let's try and get this at least a slight